Hi everyone. This Unit 2 mini lesson is going to be all about solving linear equations. So our focus today is going to be on two properties that we will use to help us solve linear equations. But before we jump into that, I just want to talk about why we're covering this and why we're studying this. We solve problems every single day. So in Unit 1, we talked about some real world problems we had and the solution that we tried or used to help us solve the problem. So in this course, when we're looking at numbers and the math, we still find value in it because we use critical thinking when we're solving equations to attempt to solve for unknowns. And we do that in our daily lives. We always are using reasoning and critical thinking to attempt to solve for various unknowns without even knowing it. So solving equations in this course is also the best way to become adept at understanding what equations tell us and how to use that critical thinking and reasoning to isolate a variable or solve for an unknown. So let's first talk about what a linear equation is. A linear equation is an equation that involves only first degree polynomials. So we're not going to see x to the thirds or a squareds. We're going to see just a variable raised to the first power only. For example, 3x plus 5 equals 7 is an example of a linear equation because the variable x is only raised to the first power. So you will not see any higher powers. In this example down here, 3x squared plus 5 equals 7 is not a linear equation because the variable is raised to a higher power. So the big thing we're going to focus on in IntelliPath this week is solving a linear equation and using some various rules to do so. And we're going to talk about two of those right here, the addition property of equality and the multiplication property of equality. And before we jump into those, let's just talk about what we even mean by solving an equation. To solve an equation means to find out what the variable is equal to. So you may see x, you may see m, y, a. The letter can really be anything, but it represents an unknown. So we want to come up with an equation of the form x equals, a number or an expression. And when we have it as x equals or a equals, we've got our solution. We've solved for x. So notice that the variable is alone on one side of the equal sign, and then the number or expression is on the other. So the big question is, how do we get that variable alone? And so we're going to use two operations in this mini lesson to either eliminate or move everything else over to the other side. And the one thing we want to keep in mind is when we're solving an equation, whatever we do to one side, we must also do the exact same thing to the other side. And this is called what I like to call the golden rule. So if you think of an equation as like those balance scales that you might have seen in a chemistry course or even just, Lady Justice, they're perfectly balanced, these scales. The left is exactly even with the right. But if you start removing weight from the left side or adding weight to the left side, but you don't do anything to the right side, all of a sudden the scales are no longer balanced. But if you remove, say 2 coins from the left side and you also remove 2 coins from the right side, your scales remain balanced. So that's a good visual to remember as you're going through this. So whatever you do to one side of the equation, you must do the exact same thing to the other side. If we would add something to the left, we must also add something to the right. So let's look at our first property, the addition property of equality. This states that you can add the same amount to both sides of an equation and it will remain equal. So what I want you to think about is addition and subtraction are inverse operations. If something is added to x or y or whatever your variable is, and you want x or y alone, then you're going to subtract that value from both sides in order to eliminate it or move it. Okay, and if something is subtracted from your variable, you're going to add it to eliminate it or move it. So, for example, if you're asked to solve this linear equation, x minus 3 equals 9, since we have a minus 3, we are going to add 3. We're going to do the inverse operation. We're going to add 3 to both sides of our equation to isolate x, or to get x by itself. So here you can see that I added 3 to both sides of the equation. Whatever I do to one side, I must do to the other side. And so the minus 3 and the plus 3, they are eliminated. They add up to 0, right? Which is what we wanted to have happen. And then on the right side, we're going to combine the 9 plus 3, which gives us our solution of 12. X equals 12, which means x is 12. And an important thing when you're solving equations is always to try to take your solution and check it back into the original equation to see if you get a true statement. So notice right here, if I would take, I'm saying x is 12. So if I would take 12 and substitute that in for x in the original equation, I'm going to get 12 minus 3 equals 9. So all I did was substitute in 12 for x. And we know that 12 minus 3 is 9. So on the left I have 9, and on the right I have 9. So when we get 9 equals 9, we know we have a solution that works. We know our solution is true. So here's, oh, that's the same example, sorry. I just broke it out into a bigger slide. But let's say we've got, I'm going to change it up on us. Let's say this is plus, okay? So we've got x plus 3 equals 9. Now, instead of adding 3, we are going to subtract 3 on both sides, okay? And so let's just switch it up. So we're going to subtract 3 on both sides of the equation to isolate x. So this would be 9 minus 3 now. So let's pretend that that's gone. And this was x plus 3. Now this becomes minus 3, right? So I just subtracted 3 on both sides. So the plus 3 and the minus 3 on the right, I'll change colors. The plus 3 and the minus 3 on the right are eliminated. And then we have 9 minus 3, which gives us 6. So if we were to plug in 6 into this equation, we would have 6 plus 3, and we know that that equals 9. So we know that in fact we would have a true statement, and x equals 6 would be the solution to our equation. The second property we're going to talk about is the multiplication property of equality. And the multiplication property of equality states that you can multiply the same amount to both sides of an equation and it will remain equal. So again, multiplication and division are inverse operations, and we want to think about the inverse. We want to think, how do we undo a certain operation? How do we eliminate it? And so if something is multiplied by x, or whatever the variable is, we're going to divide to eliminate it. And if something would be divided from the variable, or if the variable would be divided by some value, we would multiply to eliminate it. So in this example here, I have 3 times x equals 6. So 3 is times x, and therefore I'm going to do the inverse. I'm going to divide both sides by 3 to eliminate that 3 that is times x. And then we get x by itself on the left, and we have 6 divided by 3, which is 2 on the right. So we solve when we get x equals 2. So notice that if I would plug 2 back in for x in the original equation, we would have 3 times 2, and that does equal 6. So we know that 2 is the solution to our equation. Now sometimes you're going to have more complex equations. Sometimes you're going to see something like this, where you'll notice you're going to need both the addition property of equality and the multiplication property of equality to isolate x. So if we need multiple properties, if we would need both of these, we're going to start always with the addition property of equality. So I would first start by moving whatever would be added or subtracted to my variable, okay? And so in this example here, I would want to first subtract 3 from both sides so that I could eliminate that plus 3. So I subtract 3 from both sides, and that gives me 5x on the left, and 18 minus 3 is 15 on the right. Now, x is still times 5, and remember, to solve this, we want x by itself. So to undo the multiplication, I'm going to divide both sides of the equation by 5. Whatever you do to one side, you must do to the other side. So 5 divided by 5 is 1, so we have 1x, or x, is equal to 15 divided by 5 equals 3. So I'm going to ask that you guys perform this check to see if this solution is in fact correct. And if it is, you're good to go. If you do not get a true statement, please reach out to me and we can walk through it together. So always check your solutions after solving. It can really help you catch a mistake and also be confident in your answer. So I hope that this helped. If you have any questions, please reach out to me. I'm happy to help. You can instant message me or email me. And so let me know if you do have questions. Use this before you finalize your IntelliPath for Units 1 and 2, and I will talk to you soon.